All right, here in section 5.1, we're going to look at the basics for radicals and rational exponents. So up here, um, they give you some key terminology to look at. Really, the big ones for today are understanding what a radical is. So a radical is anything that has this symbol right here. And you're probably familiar with square roots. Um, but today we're going to look at all bunch of different roots. So you're going to square roots, cube roots, fourth roots, fifth roots. We could go higher, but you're going to have a bunch of different radicals we're working with. The radicand is going to be any number under the symbol. So in this example right here, our radicand would be 4ac. So it's just the value under the symbol. And then the big thing, really, like as far as this terminology goes, that we have to worry about here are odd roots are going to have one solution. Even roots are going to be plus or minus. All right. So first semester, when you were solving equations and we were to take the square root of a number, we had to account for the plus or minus. A square root is an even root because really square root is just the second root. Um, and then we're only going to use the plus or minus when we're asked for all real roots. Okay, so if it does not ask us for all the real roots, you're just going to leave the positive number. But if they ask for all real roots and we're taking an even root, have to include the plus or minus. So jumping right into example 1 here, they want to know what are the real roots for these two different numbers. So really what's going on here for A, they want all the real cube roots of 125. So the way we would write that is the cube root of 125. And then we're asking ourselves, okay, what number multiplied by itself 3 times is going to give us 125? Okay, so you're going to have the same number going 1, 2, 3 times. And when we multiply it, it has to equal 125. Okay, this is something you should be able to do in your head. So if I look at this, 5, 5, 5. If I go 5 times 5, I get 25. Multiply by another 5 gets me to my 125. So the cube root of 125 is going to be 5. B, they want to know what are all real fourth roots of 16. So the way we write that, we have the fourth root of 16. And then now it's what number multiplied by itself, 1, 2, 3, 4 times is going to equal 16. Okay. Another way you could think of it is what number raised to the fourth power is going to give me 16. In this case, it would be 2. And then going back to our vocab, we know when we have all real roots, okay, so right here it says all real roots, and we're dealing with an even one, we have to make sure we include the plus or minus. Okay, so all real fourth roots of 16 would be plus or minus 2. Okay, so that's example 1. The try gives you some practice with that. For example 2, instead of having it like written out in words, they're now going to like give us rational exponents, which rational just means fraction. Okay, so we're gonna have fractional exponents from now on. Up top, they give you some terminology. The big takeaway from here is when you have a fraction as an exponent, the denominator is telling you what root to take, and then the numerator is the exponent we're raising it to. So for example here, they give us x to the 4/3 is the same as the cube root of x raised to the 4th power. Or you could also do it opposite. We have the cube root of x to the 4 under the symbol. I will tell you this, in this class, 99% of the time, we are using this setup right here. Okay, I like to work with smaller numbers. So like the first thing we're going to want to do is take the root and then raise it to the power. So what that would look like in example 2a is I have 16 to the 1/4 power. That's telling me that I want the fourth root of 16, and then we are raising that to the first power. Okay, and the way you would do that is take the root first. So what times itself 4 times equals 16? It would be 2. And then we raise it to the first power. Well, 2 to the first power is just 2. Okay. Notice on this one, they didn't say like all real roots. So I don't have the plus or minus there. All right. I just have 2. For B, a little more tricky. If I want to rewrite this, 27 to the 2/3, that's telling me to take the cube root of 27. And then when I'm done, I want to square it. Okay, same deal. You should be able to do this in your head. Okay, what multiplied by itself 3 times gives me 27? We'll start with a low number and work your way up. 2 times 2 times 2 is 8, so obviously that's no good. Go to 3. 3 times 3 is 9. Times another 3 gets me to 27. So the cube root of 27 is going to be 3. And then we want to go ahead and square that, which gives me a value of 9. Okay, so you need to be able to switch from a rational exponent to a radical. So remember, denominator is the root we're taking, and then the numerator is what we're raising it to when it's all said and done. So you got a couple examples on the try it to go ahead practice evaluating. And then when we go to example 3, it's more of the same. So they're just asking us to evaluate these. And I'm going to follow the same steps. So step 1, rewrite it. So I got the 5th root of 32. And then I want to raise that to the 3rd power. So 5th root of 32 is saying what times itself 5 times gives me 32. Well, I mean, it should be easy. Like, it's going to be 2, okay? If you don't realize it's 2, actually write it out and show your work. But if I go 2 times 2 times 2 times 2 times 2, it's going to get me to 32. So the 5th root of 32 is 2. And then we have to raise that to the 3rd power. Don't make the silly mistake of doing 2 times 3. Realize it's 2 times 2 times 2. So 2 times 2 is 4. Times another 2 gets me to 8. And then for B, this is where people always fall apart. You need to remember from Algebra 1, when we have a negative exponent, that means that in our fraction, we have to flip the radical down below. So this turns into 1 over 27 to the 2/3 power. Okay, so whenever you have that negative exponent, it jumps over the fraction bar. And then from there, we're going to follow the same rule. So we got 1 over the cube root of 27. We got to square it. Cube root of 27 is 3. So I have 1 over 3 squared. Leaves me with 1/9. Okay, so that's examples 1, 2, and 3 for section 5.1.